Objective 16, be able to use the concepts above, so on objectives 1 through 15, molar ratios, solutions, and gas laws, with stoichiometry to determine your reactant or product. And this one's actually not as overwhelming as it looks, so take some deep breaths when you see a problem that looks pretty involved. When potassium chlorate, so that's going to be K, and I have to look and see what chloride is, ClO3 I think, but I don't want to mess it up. ClO3 -1, so it's just be KCl, oh, I didn't mean that, KClO3 is heated in the presence of a catalyst such as manganese dioxide. It decomposes to form solid potassium chloride and oxygen gas. Now this manganese dioxide, that's just a distractor. It says right there it's a catalyst, so it is not part of the balanced equation. So I'm going to go ahead and insert my arrow here. And I'm going to indicate my products, potassium chloride, KCl, and oxygen gas. So to balance this, I'm going to need 3 oxygen, 2 of those, which means I need 2 of these. And it says how many liters of oxygen should be produced from 1.25 kilograms of potassium chlorate. Well, 1.25 kilograms is 1,250 grams. And if I divide that by the molar mass of potassium chlorate, I'm going to have potassium at 39.1 plus the chlorine at 35.45 plus the 3 oxygen at 48. So 122.55. So 1250 divided by 122.55 is going to be right around 10, or 10.2 moles of potassium chlorate. And if I know how many moles of potassium chlorate I have, I can look at my balanced equation and see that I should be getting 3 moles of oxygen from every 2 moles of potassium chlorate. So when I multiply this by 3 halves, or 1.5, so 15.3 moles of O2 is what we're talking here. And now we're being asked to come up with that as liters of oxygen. So I'm being told the conditions are 0.98 atmospheres, 10 degrees Celsius. So I have to go ahead and plug this into PV equals nRT. And my pressure is being given as 0.98 atmospheres. My volume is what I'm trying to find. I have 15.3 moles. My R value, because now I'm using atmospheres, is 0.0821. I should have put this in kilopascals because that's typically what IB will give you. Or they might give you pascals and make you divide by 1,000 to get kilopascals. And then my temperature, I have to remember to convert, add 273 and convert it to Kelvin. So solving for V, I'm coming up with a volume of 15.3 times 0.0821 times the 283 and dividing by 0.98, coming up with a volume of 363 liters.